This slide shows a control relay with a normally open contact and a normally closed contact. The hardwired ladder logic on the left shows a switch controlling the relay coil and the normally open contact controlling a red pilot light and the normally closed contact controlling a green pilot light. When switch S is open, the coil of the relay will not be energized and the contacts will be in their normal state. The red pilot light will be off and the green pilot light will be on. When switch S is closed, as is shown on the right, you can see the coil is now energized and the contacts have changed state. The red pilot light will be on and the green pilot light will be off. The hardwired circuit has been converted to a PLC ladder logic. In the simulation, when switch I:1/0 is open, the OTE instruction, representing the coil of a relay, is not energized, and the XIC instruction on rung 1, representing a normally open contact, is false, and the OTE for the red pilot light is off. On rung 2, the XIO, representing the normally closed contact, is true, and the OTE representing the green pilot light is on. When switch I:1/0 is closed, the OTE instruction is on, the XIC on rung 1 is true, and the OTE for the red pilot light will be on. The XIO on rung 2 will be false, and the OTE for the green pilot light will be off. A motor starter is a combination of a contactor and an overload relay. An overload relay is required for the protection of all motors. This slide shows both the hardwired control circuit and the power circuit for a three-phase magnetic motor starter. If the motor is not running and the stop switch is not pushed, when the start switch is pushed, the coil of the magnetic motor starter will be energized. The auxiliary contact M in the control circuit will close, so when the start push button is released, the coil of the magnetic motor starter will remain energized. The three normally open M contacts in the power circuit will also close and supply power to the motor. If an overload of the motor is detected, the normally closed overload contact will open, which will de-energize the coil of the magnetic motor starter and remove power from the motor. Pressing the stop button will also remove power from the motor. The control logic of the hardwired motor starter can be converted to PLC ladder logic. The start, stop, and overload are connected as inputs to the PLC. The coil of the magnetic motor starter is connected as an output of the PLC. You can interpret the PLC logic by starting with the output instruction M. M will be on if the OL input is closed and the stop switch is closed and either the start switch is closed or output M is on. This is a simulation of the motor starter logic. Pressing the start switch will turn on the starter coil. Pressing the stop switch will turn off the starter coil. When the starter coil is on, opening the OL switch will turn off the starter coil and it will not turn on again until the overload switch is closed.